Awesome. Thank you so much. Hi, everyone. My name is Ahmed Khan. I'm a solutions architect, and I support some of our strategic customers here on the West Coast. And today I'm going to be talking about Amazon Lex, some of the concepts surrounding Amazon Lex. And then, as more specifically, I'm going to be talking about how you can integrate your Amazon Lex chatbot with any messaging service. The example messaging service that I'll be using is in this example is Twilio SMS. For those of you who don't know about Twilio, it's a third-party service that lets you very easily integrate SMS messaging within your applications. So let's quickly go over what we're going to be covering today in today's presentation. So first and foremost, again, we'll be talking about Amazon Lex, why do we need Amazon Lex, what value it can provide you. And so at this point, it's important to point out that Amazon Lex natively provides a few different built-in integrations. So if you have a very simple use case where you have perhaps a single bot that you're trying to integrate with the Facebook Messenger, Slack, or Twilio SMS, you're probably better off using the built-in integration available in Amazon Lex console. But if you have any of the other services that you might want to integrate with the Lex chatbot that are not currently supported, or you're trying to build a more advanced solution that perhaps consists of multiple specialized bots, and you want to implement custom business logic and custom routing in front of Amazon Lex, then this solution might be of interest to you. Any of the applications that are not supported, you can use the solution that's going to be discussed in this webinar to implement those integrations. The way I've implemented this solution is there are many different ways. The way I chose was to build a serverless solution. And whenever I say serverless, what that really means is that I don't need to manage any kind of servers. The AWS platform handles that for me. It handles the high availability. I don't have to worry about running my instances in different availability zones and manage and patch my OSs. All I do is really focus on writing code that implements my business logic and provide that code and configuration to the respective AWS services, and they take care of the high availability and scalability of my solution. So the other services that are components of this solution that I'm going to be presenting today are AWS Lambda and Amazon API Gateway. So we'll briefly touch upon that. We'll discuss those two services, what benefits they bring before we dive into the actual implementation of the solution. We'll talk about how you can teach your bot how to text with Twilio SMS. That's the solution. Once we're done with discussing the solution, we'll have a quick demo, and following the demo, we'll talk about how you can add support for voice. Amazon Lex supports both voice and text, and once you have the chatbots built and deployed, it's very easy to add support for voice. All right, so let's quickly talk about Amazon Lex and what it provides you, and why there is so much excitement about chatbots these days. So if you think about it, for perhaps maybe the last few years, more than a decade, perhaps any kind of application that's running either in on-premise and in your data centers or in the cloud. Your end users interact with that application through a graphical user interface. And what's so exciting is that with all the advancements in artificial intelligence and machine learning, what we are seeing is a new kind of interface. And that interface is the conversational interface. And what Amazon Lex really lets you do, it really democratizes this conversational interface. Um, and so it provides both Lex, it provides both text and voice support. And what you might ask, why, how is Lex democratizing this? And what's so hard about creating a conversational interface? But if you want to look at that, there are two major pieces of technology that you have to build if you want to really implement a true conversational interface. First is speech recognition. So any kind of input, any kind of audio input that your user gives to your application, you need to decipher what the user is trying to do. The second piece is the natural language understanding. So if you have a verbal command, you can use the speech recognition portion to convert that into a set of words. And then your application really needs to understand the relationship between those words and then decipher what the end user is trying to do and trying to accomplish. And those two things are not really easy to implement. This is something that Lex provides out of the box, and you can very quickly get started by using these already built-in technologies to quickly build a chatbot. And last but not least, it's worth mentioning that the deep learning that powers the speech recognition and the natural language understanding is the same engine that powers Amazon Alexa as well. So it's very easy. You don't need any kind of artificial intelligence or machine learning skills to create a chatbot using Lex. And you can very quickly log in into the Lex console and create a fairly sophisticated chatbot in a matter of minutes. And there are a few example chatbots within the Lex console as well. But before you do that, it always helps to understand some of the concepts and terminology that's being used within Amazon Lex. First and foremost is the intents. And the way to think about intents is just the menu of options. If you go back to a graphical user interface, you have a menu of options. Similarly, you would have a menu of options that your chatbot will support. And those are essentially intents. Now, obviously, we don't have a graphical user interface, so the user is not able to see a list of menus. So how does the chatbot then really find out what the user is trying to do? What is their intent? And that's where the machine learning model comes in, and that's where the utterances come in. Utterances are essentially phrases that the user can speak or write as a text message or any kind of message that can then map to a specific intent. So, for example, in this scenario, we have book hotel. So a phrase like "I'd like to book a hotel room" will translate and map to an intent, the book hotel intent. And once the chatbot, the Amazon Lex chatbot, deciphers what the user intent is, it sort of goes into an interview mode where it will ask a series of questions and try to fill out and gather all the required information that it needs before it can fulfill that intent. And that's where slots come in. So slots are essentially, if you think about going back to our graphical user interface example, slots are kind of like form fields that you're filling, except in this case, the form is automatically being filled out by the chatbot on your behalf. So once we have all the required slots, for example, booking a room will require a city name and what date you're trying to check in, how many nights you're staying, and so on and so forth. Once the bot has all the required slots, it can then call a code hook within Amazon Lambda to book the hotel room and then get a confirmation back to the end user. So let's dive in a little bit and really understand what's going on under the hood. So in this example, we have the same intent, and we're using a audio input, and the user says, "I book a hotel in NYC." And here, there's one thing to note here is this user is specifying an intent, which is book a hotel, and secondly, the user is also specifying one of the slot values, which is the city where they want the room to be booked, which is NYC. And if you notice, they're specifying the city as NYC and not like New York. So there are many different patterns that are supported for many different slot types. For example, you can say tomorrow for tomorrow's date instead of typing in the whole date. The first piece, within Lex, is the automatic speech recognition. So the audio stream that comes in, book a hotel in NYC, is converted into a set of words using the automatic speech recognition, which then passes on the series of words to the natural language understanding engine. The NLU engine then looks at the series of words, tries to understand the relationship between those words, and then tries to decipher the end user's intent. In this case, it's able to decipher two things. Number one, that the user is trying to book a hotel, and secondly, they're trying to book a hotel room in New York City. So now that this goes in, and they will ask any other the bot will go into the interview mode and ask the check-in date, the checkout date, the type of room, and so on and so forth. And once it gathers all the required information, it goes and asks for the user's confirmation. If the user gives the confirmation, you can use a Lambda code hook to book a room. The response, the confirmation, and that is then relayed back from Lex. And in this instance, we're using another Amazon service called Amazon Polly that converts the written text into speech, and the speech response is relayed back to the user. So before we dive into the solution, I want to quickly touch upon AWS Lambda and API Gateway, the two other components, like I mentioned before. AWS Lambda is really an event-driven compute service. It's a serverless service. So again, you don't have to manage any kind of servers, do any kind of OS patching, or worry about high availability. AWS Lambda takes care of that. You're essentially providing only the function code, and you pay for the number of invocations of that function and how long that function actually takes to execute. AWS Lambda has been, there's a lot of excitement about this service, around the service. It is interesting to folks that are trying to refactor their monolithic applications into a microservices architecture, into 12-factor apps. And it's also very interesting to people that are trying to react to different events within their AWS infrastructure. So if you look at the components, again, what you're doing is essentially writing the business logic, and that's all you have to worry about. So you write your business logic as a set of functions, and each function you provide to the AWS Lambda service. The Lambda service, which is the third bullet point here, takes care of provisioning that code. It takes care of making sure that it's executed in a timely manner, and that your code is highly available and the execution environment is set up correctly. The other piece of information that you need to provide to Lambda is the event source. Now, obviously, you're specifying your logic as a series of code functions, and there are many different languages that we support, including JavaScript, Python, PHP, and .NET, to name a few. But you have to specify the event source that triggers the Lambda function that you've written. That event source could be another AWS service. Lambda actually integrates with a growing list of other AWS services. And in our instance, that event source is going to be an API call that's made to the Amazon API gateway. The last thing that Lambda provides you is gives you the flexibility to run this within the AWS Lambda networking infrastructure, or choose between that, and you can choose to run a function within your own VPC as well. So there are a couple of different networking options available for you depending on your security needs. The next service, which is also a serverless service, the solution is completely serverless, is Amazon API Gateway. It's a fully managed API service where you define a series of routes. And for each of those routes, you will define a series of methods that those routes actually support. You can create, like any other AWS service, you can create the API through the console, by making the API calls, or through the CLI. You configure it. So you tweak. You can tweak the input and output parameters and transform them. It provides a full publishing capabilities and versioning capabilities for you to deploy different versions of the API. You can also monitor the usage of APIs. It provides you a lot of additional capability in terms of security and monitoring of your APIs. You can define fine-grained access control on who can access your API. There are various methods of authentication and authorization that are supported on Amazon API Gateway. And then it provides additional security measures. For example, you might want to throttle an individual users on their usage of your API, and you can that functionality is built in within the API Gateway. So let's quickly take a look at a screen grab here of what the API Gateway looks like. Here I have my definition where I have a route called /lists, followed by list ID, and then followed by another a URL path called items. And under that path, I have declared a definition for a post method. And so any application that I authorize can do a post request to this URL. And you will see these four different sort of cards here that represent different functionalities, capabilities within the API Gateway. And on the right-hand side, you'll see the back-end code logic that you've implemented. In this case, it's a Lambda function. So right here is the Lambda function. Any request that's coming in has to adhere to a certain format, and that format, an authorization, and it has to come to a certain URL. That's all defined in the method request portion of the API Gateway. The request then moves on. Once it passes the security checks and whatnot, it passes on to the integration request. The integration request is the place where you define your transformations. So, for example, your inbound API format perhaps is different than your backend logic that you might have implemented at a different time. And so you can do your transformations. You can map one parameter and rename it to a different parameter, and so on and so forth. And that you can do within the integration request. The integration request then reformats the incoming request and passes it on to the backend function. The backend function then responds likewise, and it goes into the integration response. So for example, this Lambda function could respond in a JSON format back to the integration response. And then you can use the integration response over here to convert the JSON reply to an XML format, and then pass it on to the method response, which is your external response format for your API. So that's sort of a quick overview. Again, it's both of these services are serverless, so you don't have to worry about like provisioning any kind of infrastructure for these, and you pay for as much as your users make use of your application. All right, so let's quickly talk about the solution and dive into the solution details. Here I'm going to be showing you how to integrate an Amazon Lex chatbot with Twilio SMS. Now keep in mind, I'm not going to be discussing the creation of the chatbot itself. There are many different posts. You can go and follow instructions and read some blog posts on the Amazon AI blog, or you can watch some of the earlier recordings of this webinar series to find out how you can quickly create a chatbot. But very quickly, you can log into the console and using one of the example chatbots, get set up with a simple chatbot very quickly within minutes. So once you have that a chatbot, how can you integrate that with a third-party app is what I'm going to be talking about. So let's look at the solution at a very high level. What we're essentially trying to do is teaching your chatbot how to text. And the way it works is you will allocate a phone number for your chatbot where your users can send text messages to the chatbot. And that number is provisioned by Twilio Programmable SMS. So you'll use a Twilio SMS service to provision the phone number where your end user can send a text message. So in the message flow, once the message is received by Twilio, Twilio will then ask us what we want to do with that that SMS. It says, okay, I've received a text message, and it'll make a post call to our Amazon API gateway where our API resides and ask our application, hey, I've received an SMS. What do you want to do with it? The message body of that SMS is then processed by Lambda, the Lambda function that you're going to implement, and pass that on to Amazon Lex. So, for example, if you have a hotel booking bot and your user sends a message saying, I want to book a hotel room, that message is relayed to Amazon Lex, which responds back to the Lambda function in its own format. The Lambda function then relays that message back to the Amazon API gateway and goes through the Twilio SMS to your end user, which the end user then receives an SMS message in response. So like I said, if you have a very simple use case, you could use the built-in integration that's provided within the Lex console. But this is an example scenario of perhaps a travel booking site that is trying to add a conversational interface to their application. And within a travel booking site, you could have a cruise. People can come in and book cruises or flights or hotels, which are very specialized tasks. And so the travel booking site has decided to implement these specialized tasks as separate specialized bots. And so in this instance, there's a concierge bot that really acts as a receptionist to the user. The user sends a message, says, I want to book a cruise, which is relayed through our application to the concierge bot. The concierge bot then understands the intent of the user. It says, okay, I understand that the user is trying to book a cruise, so we really want to forward any incoming messages from now on to the cruise booking bot. But before it does that, the Lambda function, the logic that we've implemented goes ahead and stores this session of this user, which contain the user's phone number, what is their current intent, which bot is going to handle the current intent. And I'm using a new Amazon DynamoDB feature called the TTL, which is the time to live. And the example here shows that perhaps you want to store the user session for maybe 5 minutes or 10 minutes, and then automatically expire that session. So the DynamoDB table will automatically delete that according to the TTL that you provided. Any incoming messages from then on, user then is relayed and sent to the cruise booking bot that specializes in booking a cruise. So this is the kind of design where you will need multiple bots and perhaps need a logic layer in front of Amazon Lex, and this is where a custom integration solution like what I'm presenting today might be useful. So the first step in doing this is, so for this example, we're using Twilio SMS. And if you haven't used Twilio SMS and just want to play around with it, it's a great tool for integrating SMS into your applications. And they provide a Twilio trial account. And as part of the Twilio trial account, what you can do is allocate a free phone number, and you can send and receive text messages to that phone number. The only thing to note here is that if you have a Twilio trial account, you will have to verify any phones that want to communicate to your Twilio number. So before you can send messages and receive messages, SMS messages from this Twilio number, you'll have to verify, for example, your own cell phone number. And that restriction can be lifted away by upgrading to a full Twilio account. The other thing that it would do is add a little preamble to your text messaging, saying that this message is being sent by a Twilio trial account. And so you will log in, and you can get a free Twilio number. You can then specify in the first setup, in the first step, you can just get a number and then keep a note of the auth token that you'll be using later on to authenticate any incoming request in your Lambda function. So make a note of that. The second one is where we implement some code. Now, before I jump into the code and try to explain some of the highlights here in the code, I want to quickly mention that we are going to have a companion blog post that will give you step-by-step instructions on how you can replicate this setup. This code will also be available on GitHub. So we're going to have a companion post. So on the left-hand side, we have a IAM policy that I want to quickly go over before going into the actual Lambda function and trying to explain the Lambda function. So security is the #1 priority at AWS, and even when you're signed in and you create a Lambda function, by default it doesn't have any kind of permission to access any of your infrastructure, any of the other services within AWS. And you have to explicitly provide that permission. So before we go ahead and code our Lambda function, you want to have an IAM policy. And this IAM policy, I want to quickly note that it has two statements. Essentially, the first statement is allowing the Lambda function to post log messages to CloudWatch. And more notably, there's a second statement in here that lets you specify that and give permission to Lambda to use the post text API call for Lex. So you need that permission for Lambda to actually access that API call within Lex. Next, we define our Lambda function, where we give it a bunch of information that is needed. The first one is your bot alias, the name of your bot, the bot alias, the bot name, the input text that's coming in through the Twilio SMS, the end user's phone number, and any session attributes, which in this example, I did not implement any kind of session attributes here. Once we have that information, then we use the post text API for the Lex runtime. And here, the first thing that we are doing is creating a Twilio TWIML object. Now, I want to take a break and talk about TWIML. Once Twilio receives a text message and it sends out a request to your application as an API call, there has to be a mechanism where you can tell Twilio what to do in response to that text message. And Twilio expects that you will tell it what to do in a specified format. It's an XML-like language, a Twilio-specific language called TWIML. And so you can specify various commands as elements, as XML elements, and send that response back to Twilio, and Twilio will take that action on your behalf. So here we are creating that TWIML response object, and if there's no error, we're coming back and grabbing the response that we get back from Amazon Lex, encapsulating that in a TWIML format, and sending it back to Twilio. So that's essentially, and as you can see, I've redacted some of the code, but it's a very simple implementation. The code isn't that long. Now, you keep in mind that for production use, you might want to implement some more security logic, and that's going to be included in the code that's going to be made available on GitHub. So you'll be able to uncomment some code and implement some security rules in there. So your function will not execute and will not post to Lex unless the request is coming in and is authenticated, and it's coming in from Twilio, for example. So that's our code. The next step is creating our API gateway. And so instead of provisioning servers and then provisioning my web server and then defining routes and whatnot on those web servers and making sure that I have multiple web servers in different availability zones to make my API highly available, I've just decided to use the Amazon API Gateway in this instance. Now, this is defining the API. Once you understand the workings of the API Gateway is fairly easy process. But it is a little bit involved in the sense that you have to go in and you have to know exactly which parameters are being passed in by Twilio. And so that step-by-step instruction is going to be included in the blog post. But here, at a very high level, what I'm trying to do here is within the method request, you see that there's no authentication. The authentication can be implemented in the Lambda, but you can provide any authentication mechanisms. There are various different options for authentication and authorization within API Gateway. The next is the integration request, where I go in and I take the input parameters that Twilio webhook is providing me, and then I reformat them into a specification that is being expected by my Lambda function here. And if you see my Lambda function, that's my book trip Lambda function that's being executed. The Lambda function actually comes back and responds within a JSON format, which is then converted into a TWIML format by the integration response piece. So once we've implemented this, you can test that out. You can test your API out very quickly using the test hardness here. And this is a very important point about both AWS Lambda and API Gateway, that both of these services actually provide you with a test harness that's built into the console. So it's very easy to test out services before you put them into production. So once your API is ready, you can go ahead and publish it. And once you publish, you'll get an invoke URL. Make a note of that invoke URL, and we'll use this invoke URL in our last step, which is configuring the Twilio webhook. Now you'll go back to the Twilio console where you provisioned your phone number. Once you go into the configuration for the phone number, you'll see this, that for messaging, we're specifying that when a message comes in, I want a webhook to post all the details about the messages at this URL, which is the URL of our API gateway. The API gateway is hooked up with our AWS Lambda function. Now, so that's all there is to it. At this point, you should be able to send text messages to the bot. So here, if you're able to see my screen share, I have provisioned this phone number. Now, if you made a quick note of this phone number and tried to text to this phone number, you won't get a text message back, only because this is a trial account that I'm using, and only because you'll have to verify your phone number before you can send or receive text messages. So here I go in and I will specify I want to NYC. And so I get a response back right away. So a couple of things to note here. First of all, it's a trial account, so you see that preamble. And secondly, you've noticed that I have provided an intent, which is that I want to book a hotel room. And then secondly, I've provided one of the slot values as well, which is NYC. And it recognizes both. And so it moved on, the chatbot actually moved on to asking me the next question is, what day do you want to check in? Now, instead of providing an actual date, which is properly formatted, I just do this, where I say, okay, I want to check in tomorrow. It will automatically understand what tomorrow means. And that's a capability that's all integrated within Amazon Lex. I give it the number of nights that I want to stay and the type of room that I would like. And so we have a confirmation prompt at this time. So this gives you an example. I don't have the fulfillment code hook implemented because this is just an example. But you get the idea. Now, the great thing about using SMS is that your users don't really need to install an app to talk to your bot. They can just text your bot and do anything that your chatbot supports. So if we can switch back to the slides. So here we can see that we've implemented a texting interface, a texting conversational interface to our application, and it's fairly easy to do. What if we wanted to add voice support to this? And in the beginning, I mentioned that you can that using Amazon Lex, you can support both text input and output, as well as voice. And so with this, the beauty of this solution and using Amazon Lex is you can very quickly add that. The way you would do that with this current solution is use, instead of using Amazon Polly, you could use Twilio's own text-to-speech engine. And one way to do that is to prompt the user using the TWIML verb record. So once initially a user actually calls in, instead of sending you a text message, you can specify the record verb to get their prompt, record that audio from the user, and then pass it on to API gateway and onto Lex. When you post that message onto to Lex, you will use a different API called post content rather than post text, and you're passing on that MP3 or audio file. And Amazon Lex supports a bunch of different formats, but you will specify, in this instance, one way to do that is to specify the text/plain except header. And by doing that, what you're saying to Lex is that, hey, I'm posting this audio recording, but I want the response in plain text message. And the reason why you want to do that is because then you can transform that text into a TWIML and use the save verb and TWIML and pass that back to Twilio and let Twilio do the conversion from text to voice. So that's your that's a way using which you can add support for voice to your application. So I would highly encourage you to go to the Amazon Lex console and really play around with Lex. There's a generous free tier that's included for the first year, so you can play around and not get charged. And even when you're past that, the thresholds for the free tier, there is the pricing is almost negligible, in the sense that if you're just playing around with it, you're paying only for as much as you use. So last but not least, I want to make sure I want to give a shout out to this bot challenge that's being sponsored by Slack. So if you go and play around with Amazon Lex and you build an interesting bot that you want to share with the community, go ahead to AWS Chatbot 2017.devpost.com and submit it. The submission deadline is July 18th, and there's a significant cash prize. There's also other prizes such as reInvent tickets and AWS credits as well. So go ahead and do that. At this point, I think we're ready to take any questions.